Hi guys, welcome to Eminent Scholars Academy. So in today's class, we'll be looking into this simple question under dimensional analysis. A newly discovered physical quantity or physical law states that P equals to kMa VA over T to the power of C, where K is dimensionless and the dimensional formula of P is given as this, ml T raised to the power of minus 2. We have to determine the dimension of or the value of A, B, and C, and to also state one limitation of dimensional analysis. Without wasting much of our time, let's begin. According to the principle of homogeneity, when we have a formula like V equals to U plus AT, the principle states that the dimension of V is expected to be equal to the dimension of U and to also be equal to the dimension of AT. We are going to be applying the same thing here. K is a constant, it is dimensionless, so we can actually say that the dimension of P is expected to be equal to the dimension of K m raised to the power of A, V raised to the power of B over T raised to the power of C. This bracket here is used to denote dimensional formula. So since K is constant, we can bring it out by focusing on what we have inside as m to the power of A, V to the power of B over T to the power of C. Our m is mass, the V is speed, and T is time. Moving forward, you can use the base units. Mass is kilogram, speed is meter per second. But do not forget the power. We have A here, we have B here, and our time is seconds. So we are going to have S raised to the power of C. Then, according to the law of indices, we can have this written as kilogram raised to the power of A dot, this is meter, m raised to the power of B dot S raised to the power of minus B over S raised to the power of C. When we apply the laws of indices here, what do we have? We're going to be having kilogram to the power of A dot meter to the power of B dot seconds to the power of B. This is division. We are subtracting the powers minus C. So do not forget we are working with what? Pressure of this P that we have here. Mass, that's capital M to the power of A dot meter is to length L to the power of B dot T to seconds to the power of minus B minus C. But do not forget, dimension of P has been given to us as what? M to the power of 1, L to the power of 1, and T to the power of negative 2. Comparing the power on both sides, we can see that A is 1, and B is 2. Then the power of T, that is minus B minus C, is expected to be minus 2. So we can transfer B here because we have B value initially, that is minus C becomes 2 plus B. Minus C therefore becomes 2 plus 1, which gives us 3. To obtain the value of C, we divide both sides by negative 1. So finally we have our C to be minus 3. So we can conclude that A is 1, B is 1, and C is minus 3. And to the second question, to state one limitation of dimensional analysis. One of it is that it is unable to give us the dimension of constants, such as pi or theta or any value. Thank you very much for watching.